Massive MIMO. The delay map proposal. Presentation outline. This presentation will include a brief abstract, system overview video, scenario case video, research scope, and expected outcome. Abstract. The promising capacity and rate brought by massive MIMO systems lead to consider it as the hopeful fifth generation mobile technology, unless some challenge facing the exploitation of its optimal capacity includes inter and intra-cell interference, border user terminal coverage, uplink pilot contamination, and femtocell or cell-sub-cell interference and coordination. This proposal claims that mitigation of such scenarios can be easily achieved by exploiting the physical characteristic of general state information resources of each user terminal position in order to complete what I call the delay map. System overview. This is a conceptual model that represents a massive MIMO system. Scattering object, scattering, shadowing, and fading are normal scenarios of this system. Beta S. Each base station contains n antennas distributed on a cylindrical body. MSC. MSC connect multiple base stations using a perfect link. UT or user terminal. User terminal is supposed to have single antenna each. Synchronization. Each base station is synchronized to the same clock with the MSC. Multipath. Due to scattering environment, multipath will take place between each antenna to user terminal link. Path selection. Perhaps a selective receiver supposed in both user terminal and base station antenna. Dynamic cell occupation. Each antenna on the base station challenged to occupy as much as possible delay space on the covered region. This space will be its dynamic occupied cell. It is dynamic due to the recursive learning process of the system. As you can see, cells are not totally geographically isolated, since it is based on delay distance and CQI weight. Also, intersection between antennas will lead to the cooperative beamforming to that position. Distance vector. The position of any user terminal in the system can be seen by the antenna as a vector of two parameters, the channel quality information weight and the delay distance to that user terminal. Delay map. Each position on the dynamic cell of the antenna has its own parameters. But instead of saving all points of the cell, this time slot will be updated at each learning epoch. Initial scenario. The following scenario will present an initial case where an user terminal requests a connection to the proposed MIMO system. As you can see, it uploads a request pilot in all directions. Received timestamp. When a request pilot reaches an antenna, the antenna instantly saves its arrival timestamp and power into a vector. Because the system is synchronized to the same clock, the timestamp will be valuable to share with the system. Non-efficient paths. Links that are below a specific power threshold will be ignored by the receiver. Vector collection. Received antenna vector ID will be added to the vectors before it will be forwarded to the MSC via base station. Antenna election. After the MSC received vector from different antennas, it will elect the group of antenna that will serve the user terminal based on special algorithm. This algorithm takes into consideration the degree of freedom of the system, the timestamp, and power profile of each candidate vectors. Dynamic cell update. Each granted antenna will update its delay map cell with the new user terminal vector if necessary according to specific algorithm. Then each antenna will precode its downlink vector based on estimation from later requested pilots. After several learning process, antenna cells will be rarely updated. Thus, we are reaching convergence. After convergence, pilots from any user terminal outside the antenna delay map will be ignored by this antenna. MSC will rapidly elect antenna group to serve a new user terminal that enters any region because of its previous knowledge of antenna maps. Future channel state information of user terminal moving on a linear vector can be easily predicted. Research scope. Our research scope will include system model, multipath mitigation receivers, high precision delay estimation, delay map construction and updating, user terminal tracking, channel state information prediction, cooperative beamforming, distributed processing channel estimation. Expected outcomes: higher system capacity. Border user terminal will be meaningless. Uplink pilot contamination will be mitigated due to cell isolation. Inter-cell interference will be utilized for cooperative beamforming. Intra-cell interference will be neglected because of coordination of single antenna. Fem-to-cell or cell-sub-cell will be easily implemented. This work is a brief overview on new approach to be implemented on massive MIMO. Any ambiguous point of this presentation can be discussed in detail. Any modification and upgrades to this proposal are welcome.